And the final module will be dealing about elasticity and management tools. So in this module, we will be learning about the different components that will allow us to automatically scale our infrastructure. These components would include auto scaling, elastic load balancer, and CloudWatch. And we'll also be briefing you about AWS Trusted Advisor, right? So those are the topics for this module. But first and foremost, in the morning schedule, we have understood the importance of having an elastic infrastructure so that we can manage demand much more efficiently. And it also ensures us that we have just the right amount of capacity running at all times. But how do we actually configure our infrastructure to be auto scaling? Well, in order for us to achieve that, we need to use a triad of services that works together in harmony. These triad of services are ELB, CloudWatch, and auto scaling. So now that we are assuming that we are going to be working with changing number of instances, we need a way to be able to distribute traffic across those changing number of instances. And that load distribution will be served to you by ELB. Okay? Now, in healthy and normal operations, all of our resources in the cloud will be sending in data to Amazon CloudWatch. And remember, Amazon CloudWatch is our multi-purpose monitoring tool that is able to give you information about the performance, utilization, state, and the health of our resources. Because Amazon CloudWatch is able to ingest information in the form of metrics. Our resources are sending in metric data to Amazon CloudWatch. And metrics are time-ordered data points that numerically describes the utilization and the performance of our resources. But Amazon CloudWatch is not merely a service to store these metric data. As possible, we want to make sure that we can use this metric information. So in CloudWatch, you have CloudWatch alarms. And CloudWatch alarms will monitor a specific metric. And it allows you to define thresholds that when the conditions are met, can automatically trigger actions on your behalf. So for example, you do have the CPU utilization metric in CloudWatch, which gives you the opportunity to scale your infrastructure using the CPU utilization information or CPU utilization metric. And so if you want to scale based on that, you can create a CloudWatch alarm that will monitor CPU utilization. And you can define threshold that when CPU utilization is beyond 70%, for example, you want to trigger a scaling action. And this scaling action, when this condition is met, will need to add capacity. So auto scaling will be the service who is responsible in launching and terminating EC2 instances. Okay? And it will also communicate with the elastic load balancer, such that auto scaling is highly integrated with load balancer, whereby it will automatically register and deregister newly launched or terminated EC2 instances respectively. Okay? So that is in the response of the event whereby you need to add capacity when your servers are being overloaded. Alternatively, you can define conditions that will shrink or scale in capacity. So in shrinking capacity, you can then set another condition. If CPU utilization is less than 30%, then you want this to trigger auto scaling to remove or terminate instances. So auto scaling will do that. Furthermore, auto scaling will communicate with the elastic load balancer to say that, hey, I have terminated that instance. Please deregister or stop routing traffic to that terminated instance. Okay? So as we can clearly see here, auto scaling is able to perform scaling actions automatically in a horizontal way. Essentially, it will change the number of instances that you have, and the number of instances will dictate the capacity of your infrastructure. Okay, so auto scaling doesn't scale vertically, rather it scales horizontally, changing the number of instances. So let's dive deep into each of these services, starting with the Elastic Load Balancer. Now, the Elastic Load Balancer, or ELB for short, is the service that provides you with out of the box load distribution capabilities, where it is able to distribute traffic across multiple targets in multiple availability zones. ELB is also a smart service that it supports health checks that automatically detects and responds to unhealthy instances. And it also supports routing and load balancing across different protocols in layer 7 and in layer 4. And this is highly dependent on the type of load balancer that we are using. Speaking of the types of load balancer, we currently have four types of load balancer. Starting with the classic load balancer. The classic load balancer is a previous generation load balancer. And you only want to use this for your legacy applications that still has EC2 Classic. For the most part, this is not recommended for use, especially in the prod environment. And we would recommend you to use modern variations of load balancers, specifically the application, network, and the gateway load balancer. Now, the application load balancer operates in the layer 7 of the OSI model. It is able to handle HTTP and HTTPS traffic, but more importantly, it is able to check for the content of the request. And based on the content of the request, it is able to make a decision as to how it will segregate the traffic across different groups of instances. Okay? And that is referred to as a path-based, host-based, or query-based routing. Essentially, you have different groups of instances that serves different purposes. And with that capability, application load balancer is able to make a decision on how to route traffic to the corresponding groups of instances. Essentially, it is able to segregate traffic. And along with that, application load balancer is also able to cater and handle service-oriented architectures. So we see here an example that we have different groups of instances, three groups of instances that serves different purposes of our application. We have the mobile request, we have the API request, and we have the default request EC2 instances. But depending on the contents of the request, load balancer is able to receive those requests. And again, it evaluates the contents of each request, and based on that, along with the rules that you have defined, it is able to make a decision as to which groups of instances it will route the traffic. If the content of the request contains a path to the mobile, then it knows that it needs to route to the mobile groups of instances. If it sees in the content of the request that it has a path to the API, then it knows that it needs to deliver the traffic to the API groups of instances. And finally, if there are no paths specified, that it will route the traffic to the default groups of instances. Now, to give you an analogy, you can just imagine that you are throwing trash into labeled bins. You have a bin labeled as recyclable and non-recyclable, and even others. And you need to make a decision as to how you want to deliver or how you want to throw your trash. Where if you want to throw your trash, you need to understand the characteristics of the trash and make a decision as to which bin is suitable to throw the trash in. Similarly, application load balancer is capable of that segregation or decision-making capabilities. Okay? Now, on the other hand, you have the network load balancer. And the network load balancer operates in the layer 4 of the OSI model, in the transport layer. All right? And because of this, it now doesn't have any capabilities to read or check for the contents of the request. Therefore, it is incapable of decision making. Rather, because of that lack of decision making, its main feature is speed. Because now you only have one group of instance that you are serving traffic to. In this case, imagine the scenario that you are throwing trash into an unlabeled bin. You can basically throw anything in there. And because you don't need to understand the characteristics of the trash, and you don't need to make a decision, you can simply throw anything in there at a faster rate. And similarly, because of network load balancer's lack of decision-making capabilities, its main feature is speed. And finally, you have the gateway load balancer. And the gateway load balancer is specifically designed to be integrated with third party services or appliances. Okay? So here is a summary of the difference between the three. Essentially, classic load balancer is not to be used. Application load balancer is for decision making capabilities or segregation. Network load balancer is for speed. And gateway load balancer is for third party appliances. All right, that is the load balancing component. Next, we need to have a monitoring service because monitoring can help us pinpoint when we actually need to scale capacity. And it also helps us identify patterns and outliers so that we can define when we need to scale in or scale out. And that monitoring service is served by Amazon CloudWatch, which is your multi-purpose monitoring tool in the AWS cloud that can give you visibility into a resource usage, performance, and overall patterns. Okay? So really this is a monitoring service. But not only does it store information, you can also make use of this. You can get insights from the data ingested by CloudWatch by creating graphics and statistical analysis. More importantly, in relation to scaling, you can even create logs where you'll be able to define conditions. And when those conditions are met, it can automatically trigger actions on your behalf. Actions such as scaling actions, right? So to help you visualize CloudWatch, the fundamental unit of measurement in CloudWatch would be metrics. And metrics are time ordered data points that numerically describes the values that changes over time. For example, CPU utilization, memory utilization, and so on. Now, CloudWatch metrics does have two types. You have the standard and the custom metrics. The standard metrics are the metrics that are available out of the box, and resources send these standard metrics by default. Standard metrics would include CPU utilization, status check failed, and so on. But there are some metrics that you would want to monitor that are not available as standard metrics. And for those metrics that are not available by default, you can send them as custom metrics to CloudWatch. These would include memory utilization, page view count, concurrent users, and so on. And as mentioned, CloudWatch is not merely a service to store these metrics, but you can also get insights from them by viewing them graphically over at the AWS Management Console, or you can export these data into a third-party external statistics consumer. But more importantly, metrics also enable you to automate actions based on the conditions that you have defined. So CloudWatch alarms will monitor a specific metric, and you can define thresholds that when conditions are met, can trigger actions such as sending you email notifications or triggering auto scaling to rescale your infrastructure. So here is the example dashboard of CloudWatch, whereby you'll have access to different metrics for different services, and you'll be able to visualize them in the dashboard. Furthermore, you can also configure CloudWatch alarms that will monitor a metric and allowing you to define thresholds to be able to automate actions potentially. Okay? And the final component of our elastic infrastructure would be on EC2 auto scaling. And EC2 auto scaling is the service that grants you the ability to dynamically rescale your architecture horizontally. This is the service that allows you to dynamically create or terminate EC2 instances. And this is great for applications that are spiky in nature. Now, do note that auto scaling service is free of charge. The scaling action, the scaling mechanism is free of charge. However, the EC2 instance that it launches and terminates still follow EC2 pricing. But the auto scaling service itself is free of charge. The scaling mechanism is free of charge. And auto scaling is critical to be implemented in systems because this does improve fault tolerance as it is able to replace unhealthy instances. It also increases your application's availability. If if the traffic or the demand increases, then auto scaling will ensure that it can add capacity to meet that increased demand. It also contributes in cost optimization because when the traffic is low or when the demand is low, then auto scaling is also able to terminate capacity when they are not needed. Okay? So in order for you to have auto scaling in your environment, there are some things that you would need to define. One of which would be launch configurations. And launch configurations would answer what instances will you want to launch. Now, the definition of launch configurations are the same things that you define when launching an EC2 instance. You would need to specify the AMI, the instance type, the key pair, the security group, the block device mapping, and the user data. This will essentially answer what instance do you want to launch or terminate. Okay? Now that you know what, you need to answer where. And where can be answered with auto scaling groups. So auto scaling groups is a logical collection of similar AC2 instances, but this is also a logical place where auto scaling will be able to operate. This will be that logical container where auto scaling can scale in and scale out. Along with auto scaling groups, you also need to define some limitations. Define the minimum, the desired, as well as the maximum size of your auto scaling group. And where auto scaling behaves, it ensures that it does not go beyond the limit set. It does not go below the minimum size, and the amounts of instances will not go beyond the maximum size. Okay? And within these given limits, you are able to scale your systems accordingly. So now that we know what and where, the final thing that you would need to define would be how and when. And how and when is defined with a scaling policy. So this will be integrated with CloudWatch alarms. And you can specify instructions as to how it should scale out or add capacity, and how and when it should scale in or remove capacity. So based on your CloudWatch alarm definition, if you say that if CPU utilization is beyond 70%, then possibly you would want to scale out or add capacity. By how much, you ask, this is something that you define. For example, you possibly want to add 2 instances. Alternatively, if CPU utilization, let's say, is below 30%, then this condition will prompt auto scaling to scale in. Okay, and again, you also need to define how much instances does it need to scale in or remove. And so you can leverage these metrics, whether it be standard or custom metrics, and alarms, along with the scaling policy, will dictate when and how do you want to scale your infrastructure. And with all of these in place, you now can have a working auto scaling configuration. Where initially, let's say, for example, you have 3 instances that are fronted by the ELB, whose main purpose is to really distribute the traffic across these instances. Okay? Let's say your system experiences high traffic, high volume in demand. That high volume will be captured by your CloudWatch alarms if configured properly, and that will prompt to trigger a scale out activity. Or you can trigger a scale out activity based on a scheduled event that you've defined. But regardless of what triggers auto scaling, this will trigger a scale out, which will mean that it will launch an instance and it will attach that instance to the group. And finally, integrated with load balancer, it will communicate with that load balancer to say that, hey, I've just launched a new instance, start routing traffic to that newly launched instance. Alternatively, auto scaling is not only capable of adding capacity, but is also capable of shrinking capacity. Which in this case, if the traffic is relatively low, this again will be captured by your CloudWatch alarms, or you can schedule the event of when you want to scale in. But regardless of what prompted auto scaling to scale in, auto scaling will simply remove one instance from the group and terminate that instance. And furthermore, it will communicate with load balancer to say that, hey, I have terminated this instance, start routing traffic to this instance. And so that is how you can have an elastic infrastructure in the AWS cloud with the use of triad of services, specifically ELB, auto scaling, and CloudWatch monitoring. And the last service that we'll be going through would be the AWS Trusted Advisor. So assuming that you do have workloads in the cloud and you want to be able to verify if you are operating in following the best practices in a self-service manner. Obviously, you can always tap into our solutions architect, ProServe, account managers even, and your AWS partners to get these guidance. But there are cases where the question is quite minor and just want to get this information in the self-service manner. And for that, we give you AWS Trusted Advisor. AWS Trusted Advisor is a recommendation engine service that is able to scan your workloads and give you actionable items that you can do optionally to improve your cloud operations that follows the cloud best practices. The AWS Trusted Advisor is able to guide you across these five pillars, which are mainly cost optimization, performance, security, fault tolerance, and service limits. It is able to give you findings of things that you're doing well with a green check, things that you need to investigate with an orange exclamation point, and things that you need to be alerted of with a red circle exclamation point. But essentially, this is a recommendation engine that will guide you towards improving your cloud operation in a self-service manner. And with that, we have effectively concluded our discussion for this module. In summary, we have discussed how to make an infrastructure elastic through services like ELB, CloudWatch, and auto scaling. And we've also capped off our discussion with Trusted Advisor, our recommendation engine service in the cloud, to give us recommendations on how to further improve our cloud operations across five pillars. Before we wrap up the course, are there any questions with regards to this module? All right, it seems that everything is good so far. And so let us quickly wrap up the course before we disconnect. So let's wrap up the course. Now, remember at the start of this course, we have established that our goal is to be able to recognize terminologies and concepts that relates to the AWS platform. Moreover, our goal is to be able to discuss foundational service to keep you up and running in the AWS cloud, a minimal viable product in the AWS cloud. And so that is what we've discussed for today. In summary, our discussion led us to go through the AWS introduction, which gave you a discussion on the history, global infrastructure, and I've also given you a tour on the AWS Management Console. We've also discussed the foundational services, which includes EC2, VPC, EBS, S3, IAM, DynamoDB, and RDS. And I've also given you some demos to help you reinforce your understanding on these foundational services. And lastly, we've gone through these steps on how to make our infrastructure elastic with auto scaling, ELB, and CloudWatch, whilst also briefly looking at AWS Trusted Advisor, which is our recommendation engine service to help you, to guide you through being a truly cloud optimized organization. Okay? So again, we have achieved our learning objectives by discussing all of the modules. We have achieved the course objectives. But what is more important is for us to be able to achieve your learning objectives coming into this course. So again, if there are some pending questions, curiosities, or concerns that were not answered by this course, then feel free to let me know in the chat, and I'm happy to answer those questions. So while waiting for those questions, do keep in mind that this is merely an introductory level course. whose main goal really is to build that foundational knowledge. I believe that we have constructed a learning plan that is specifically designed for you. Where at the next step after attending this course is to allow you to take intermediate level courses like architecting on AWS, developing on AWS, and systems operations on AWS. Now, I would suspect that not all of you will be attending all of these three courses. It will be highly dependent on your roles in the organization. Okay? So now that you have that foundational knowledge, it will be much easier for us to go through these intermediate level courses in the near future. After which you can then take advanced courses or optionally even take those specialty courses when deemed necessary. Okay? So we will be working with you very closely on developing this learning plan. I believe Angel Bautista, our training BDM, who is not with us in this session, will be reaching out for you regarding future trainings with us. Okay? And that would be effectively concluding our course if you don't have any more questions or concerns. But before you disconnect, I would like to request everyone to finish the evaluation and feedback. Very similar to what you did in the morning session. Okay? So I believe you should have received a confirmation of completion at around 4 p.m., if I'm not mistaken. And that should prompt you to allow giving this course your evaluation and feedback. Now, as Vaughn mentioned, we take this very seriously. So honest feedbacks are greatly appreciated, and hopefully everyone will be able to send in their evaluation and feedback, as the process is very straightforward. That will not take you more than 5 minutes, and I believe the morning session is an attestation to that. So in order to provide your evaluation feedback, again, go to aws.training, sign in into your account, go to transcript, and under archived, you should see the option of being able to evaluate AWS technical essentials. Okay? So if you feel like the course has meet your learning objectives and I myself was an effective instructor, then please do not hesitate to provide us with your generous, strongly agree. Okay? So hopefully you can take your time. Um, hopefully you can take the effort and time to finish the evaluation and feedback, as we do use this as data points to reflect and continuously improve the quality of the training, as well as I myself as a trainer. Okay. Last thing I'd like to request from everyone. And with that said, if there are no more further questions and concerns, and everything is good on your end, and you have completed the evaluation and feedback, then you are free to disconnect. So thank you all for spending your afternoons with us in order to learn about the AWS technical essentials. Again, I do hope that we have met your learning objectives. Once you have accomplished everything, you are free to disconnect. Thank you so much. Have a good day. Have a good evening. Have a good dinner. Have a good weekend. Stay safe. And I believe I shall see you in a future class. Right? Once everything is finished on your end, you are free to disconnect. Thank you and goodbye.